Volcanic activity. What most don't know about volcanic activity is that it's influenced by things that occur off the planet. When our sun's magnetic field decreases in strength, it allows more of these galactic cosmic rays to penetrate the solar system. And because the sun's magnetic field strength has decreased, in turn, so does the Earth's magnetic field strength decrease, which allows more galactic cosmic rays to penetrate the planet. These rays scatter particles in the Earth's atmosphere, and they break them into subatomic particles because they are traveling near the speed of light. Of those particles, we have what's called the muon. Yes, the muon, M-U-O-N. These are just like an electron, but heavier, 200 times heavier, and they will penetrate the crust of the planet. Let me show you. As you see, when these galactic cosmic rays come in, they strike these air molecules and break them up into subatomic particles. And of those particles, there's the muons underlined. They found that the levels of galactic cosmic rays are in negative correlation with the sunspot cycles, with the 11-year cycle. When solar activity increases, the amount of cosmic rays decreases. And when solar activity decreases, the amount of galactic cosmic rays increase. And as we see, we are at the highest ever recorded galactic cosmic rays we have seen. And this is why we haven't been back to the moon yet, or Mars, or anywhere else outside of Earth's magnetosheath. Volcanoes with silica-rich, highly viscous magma tend to produce violent explosive eruptions that result in disasters in local communities that strongly affect the global environment. We examined the timing of 11 eruptive events that produced silica-rich magma from 4 volcanoes in Japan. 9 of the 11 events occurred during inactive phases of solar magnetic activity, solar minimum, which is well indexed by the group sunspot number. This strong association between eruption timing and solar minimum is statistically significant to confidence level of 96.7%. This relationship is not observed for eruptions from volcanoes with relatively silica-poor magma. It is well known that cosmic ray flux is negatively correlated with solar magnetic activity, as the strong magnetic field in the solar wind. Muons are far less interactive than neutrons, and so penetrate more deeply into rock. As muons pass through the rock, there are 2 different types of reactions important for cosmogenic nuclide production: negative muon capture and fast muon reactions. Negative muon capture dominates depths to about 3 meters in rock. Fast muon reactions dominate at greater depths. Both sunspot numbers and the heliospheric magnetic field show approximately 11-year cycles that superpose longer-term quasi-periodic variations called secular variations. Some of the more prominent secular variations are 3 grand minimum: the Wolf, and Dalton, and Maunder. Let me say that again: the Wolf, Maunder, and Dalton minimum. In addition, the space age has coincided with the longest grand maximum in 9,300 years. But the duration of previous maxima and the quasi-periodic recurrence of these secular variations suggests that this grand maximum is ending and the sun is entering a possible grand minimum, a modern minimum. Do you guys understand there's your global warming? we were in a solar maximum. This is 400 years of observed sunspot measurements. What we are looking at is sunspot observations in the top graph and Earth's temperature. Are you telling me nobody's ever lined these graphs up before? Listen, folks, they're lying to us about this global warming, anthropogenic effect nonsense. And it has to do with policy changes to pad their portfolios.